this agenda for today. So let's briefly look what's in the pipeline. So as the first thing, we will cover what Qt4MCU's package contains, and that means we will see what exactly is installed together with Qt4MCU's product. What things can be interesting for you if it goes about the files on the file system, and how to understand the folder structure for those. Then we will see how to build and run application from command line for both for the desktop and for the Renesas board. After we build our first app, there will be a time for getting through the CMake APIs that are a default way for building the projects with Qt4MCUs. We will see what is specific to Qt4MCUs and what things are used just from the pure CMake. You'll understand how the Qt4MCUs application build process works, how assets are converted, how fonts are connected to the Qt4MCUs application, and how all of those things are combined together to the binary. So you will have the more like the overview on what you can expect and how the Qt4MCUs is built and how it works. If it goes about building it, but it's also useful if it goes about understanding how in overall how the Qt4MCUs is built and how the concept works. After those 4 steps, we'll have short coffee break, and after the break, we will see how to configure Qt Creator, which is a recommended IDE for developing applications with Qt4MCUs. And once we will have Qt Creator configured, I will do some live coding for you to start developing our training application, which will be the more complex than the first one from the command line. And after the first live coding session, when we will have some skeleton of our application, there will be a time for taking a lunch break and getting some rest. And after we will be back from the lunch, I will cover asset management topic, which is to understand exactly what our tools during the compilation process are doing for your assets, and how you can manage those, how you can control how they are stored, and in which format they are stored, and what that means for your application. And of course, this will be followed by another live coding session, which will demonstrate how to use those things that we have just learned in the real life and the real example. This is for the first day, so for today. And shortly about tomorrow, we'll see what is different between Big Qt and Qt4MCUs, and why you could use one or not another. You will learn how to style the controls, how to provide different look for your buttons, and so on. Another short coffee break, and then we will get back to see how to translate your application to different languages. Another lunch break, the bigger than the previous coffee break, and after it, we will see how to integrate your application and your QML code, which defines the UI, together with C++ logic that can be anything. What is your backend, for example? This could be communication with other device components that you possibly would like to interact with. But this part of the training will show you how to trigger some actions, how to connect some data from the C++, the pure C++, to QML code, which is just for defining the UI. All right, so let's get through software requirements. And Microsoft Windows 10 is the only supported operating system right now. Linux support will be introduced really shortly in the 1.9 release. So there will be another operating system to work on, and the macOS support is of course planned, but we don't know right now when release date will be for it. but just to make sure that you know, and if you're going to use macOS to develop the Qt for MCUs application, it will be possible in the future, but as I said, we don't know exact date for now. Well, shortly, Qt for MCUs 1.8 for desktop is needed for this training. And in general, it comes with requirement for Qt Creator 4.15. You, of course, will need to have a CMake version, a CMake tool with 3.15 version or higher. And you will need MSVC compiler to build your app on for the desktop. And let me briefly go through the setups, so we will make sure that we are on the same page with those. And if you will have any problems, you can then refer to those things I will be doing to set up your environment if you have still some problems with it. So let me open Qt installer for you. Just a second, okay. So here it is, okay. All right, so just go through the login page. Okay, add or remove components should be selected. It will take a while to retrieve all the metadata that is needed for sure. All right, so first thing, please make sure that you have the latest releases selected on the left side. Let's go to, not this one, let's go to Qt, and just to make sure I have installed the Qt, but you don't need those. I have those for different purposes. Qt for MCUs comes with the parts of it that are needed, so you do not have to install the whole big Qt product. And let's go to developer and designer tools. Qt Creator is installed by default, but you can still need CMake, which is below, so make sure that you have the CMake selected, and we will use Ninja on this training, so please select the Ninja if you are going to follow my live coding sessions to have the tools installed as well. Let's collapse the big Qt, and let's go to Qt for MCUs and expand Qt for MCUs 1.8, and let's review what's there. So there are the boards that you can install, and the support for the hardware that you can install on your device. On this training, we will use a desktop MSVC, and of course, we will use a Renesas board, and in my case, it will be Renesas RA6M3G, and that's well expected board for this training. If you are going to follow this session with the RH850, for example, it could be a bit problematic as our application will need a touch. So this board should be the one that we are working together. But if you're going to develop the application together with me during the live coding sessions, you will still be able to follow it with compiling it for a desktop, and that shouldn't be any problem as well. So just to sum up the things for Qt for MCUs 1.8 desktop and the Renesas EK-RA6M3G, or just a desktop if you are going to use only desktop with me. Let's collapse. And the third-party tools to compile our application to the target board, we will need ARM-GCC toolchain. So please select that one. Of course, we will need well, only this, I think. Okay, right. So great, it's enough. Perfect. Well, If you are going to install anything more and you selected something that you have not installed before, you will probably need to click next. I have all those things, so I will just click cancel. Yes, I would like to close. And right now, let's focus on the MSVC compiler. This one is also a thing that I would like to show you how to install. So I just opened the Visual Studio installer and let it do something before it will start. Okay, my Visual Studio installer just decided to update itself, so we'll still need to wait a bit. It's still doing this. Just to remind you, if you have any questions, please feel free to use the chat and the Q&A section to ask the questions you have. I will try to answer those directly during the training. Perfect. So if you are going to install MSVC compiler, so we will probably then need this one. You will need to select one of the Visual Studio versions. It could be Visual Studio Community 2019, or even it could be a Visual Studio 2017 for Express for desktop. It could be also a professional one. Let's use the Visual Studio 2017 for Desktop Express as an example. I'm just clicking the modify there, and then individual components, and let's search for MSVC. All right, it does not work for some reason. Let's try once more. Okay, it's not there. So let's verify the for the professional. Something has broken during the update for the installer, I think. All right, individual components and MSVC. And let's find the proper version of it. Okay, so MSVC v142 is the one that we are going to use in this training. So just make sure that you have this version of the MSVC compiler for the architecture x64, x86 selected. All right, and the other thing, it's the Windows 10 SDK. So just let's type Windows 10 in the search bar, and then there is Windows 10 SDK. So just please select that one, and that will be enough if it goes about MSVC compiler. While in the future, we're planning to provide MinWG support for compiling our desktop version with other compiler for the Windows as well. And well, maybe the last thing right now, it could be worth mentioning that our Qt for MCUs documentation is available online. And here's the example of it. So doc.qt.io/Qt for MCUs. And here's the all documentation that is for 1.8. And there is a question, can we get the video record after the training? Sure, of course. And there will be the video available for you. But not today. It will be available for you probably 2 days after tomorrow's training. So you will receive the all recording for 2 days, but just after the whole training. And well, this is how the Zoom works. So hopefully it won't be too late for you. All right. So this is documentation. And that's it if it goes about software requirements. Right now, let's look what's installed together with Qt for MCUs installation. And before getting into directory and the folder structure, I will just explain you in overall what you are receiving together with your for instance installation. So the first and probably one of the most important things in Qt for MCUs is quick ultralight graphics runtime. What means this is the engine of our Qt for MCUs. It's a purely new part of Qt family, and that is written completely from scratch for Qt for MCUs. It shares some concept with Big Qt, but in general, it's a new thing. It's written just for microcontrollers to be optimal and fast. And this is a heart of our Qt for MCUs ecosystem that works across different platforms. And this is the common part of the whole framework. You will receive Qt Quick Controls library, which is a subset of Qt Quick Controls 2.0 that you can probably know from the Big Qt. This comes, of course, with the default styles for the controls and with the mechanics to style the buttons, sliders, and so on. So you will be able to implement your own look for your controls and still receive the skeletons for most commonly used controls in the applications. You will receive platform adaptation for the boards you have paid for. So platform adaptation is something that is connecting to quick ultralight graphics runtime. And once quick ultralight graphics runtime is requesting some blending, some drawing of the pixels on the screen or assets and so on, then the platform adaptation is responsible for passing those requests to hardware. So if your board has some GPU, for example, platform adaptation is responsible for passing all of the rendering to the GPU and to draw as efficiently as it's possible on the particular boards. And of course, this could come with bare metal implementation. And as a reference, we have also FreeRTOS reference implementation for operating systems for the microcontrollers. You will receive development tools, so Qt Creator and the Linguist tool for localization. We'll cover the Linguist tool and Qt Creator as well during the training. You will receive offline documentation files and examples with source code to go through all features and see how they work. And right now the folder structure. So let me just quickly open that one. All right. So just a second. All right. So this is my Qt installation directory. I'm on the C drive and then Qt. And let's review the tools that we have installed on the software requirements step. So the tools important for us today are the CMake, of course, which contains the binaries, precompiled binaries for the CMake. Sorry. There is a Ninja tool, which will be our generator for the CMake targets. And of course, there is a Qt Creator, which will be used by us on this training to develop our demo application for this training. And of course, there is a directory Qt MCUs, which holds all additional things that are related just to Qt MCUs, Qt for MCUs, like for example the compiler for ARM, and there are some vendor-specific things if there are any needed. All right. This is about tools, and let's get back to the root Qt installation directory. And let's focus on Qt for MCUs one. So Qt MCUs in the root, so drive C, Qt MCUs. Then there is always a version of your installation. And let's review what's there. So the first bin directory contains all of the tools that are needed during the compilation process, for example, to generate glyphs for fonts, to convert assets, so images, to the formats that are known to Qt for MCUs. There are also some libraries from the big Qt that are needed to run your app on desktop. So if you are going to use our desktop backend to verify your UI or changes to your application on the desktop without uploading that application each time after you're making changes to the device, then you can use those libraries to run your app directly on your device that you're using to develop your product. All right, compatibility directory contains some QML files that are needed by our tools, for example, Qt Creator or Qt Design Studio to still be compatible with the big Qts, as Qt for MCUs contains some QML types that are exclusive only to Qt for MCUs, and this compatibility module is providing the alternative implementation using other QML components that are available in the big Qt to still be compatible with Qt for MCUs. Demo images, as the name indicates, contains precompiled images for our demo applications and for both bare metal and the reference FreeRTOS. Let's focus on the one of those. And for all boards you have installed during the installation process, you will have all available demos. And for example, let's search for the Renesas board. So here you can find the watch demo example, which can be directly flashed on the target board, and you can then review how it works and how it looks on particular device. Demos contains sources for those precompiled demos from the previous directory. Docs, of course, contains the documentation and for example, platform porting guide, as well as there is a document that explains how to provide your own platform backend if you, for some reason, would like to implement platform adaptation for yourself and by yourself. Examples, of course, contains examples, and this is rather a simple thing. Okay, there is a question. What exactly is compatibility folder? Well, so as I said, compatibility folder contains some QML implementation based on the big Qt to cover some types that are exclusive for Qt for MCUs. So just by explaining that with an example. So if you have your Qt for MCUs application and you're going to open the project for it in, for example, Qt Design Studio, you can use this module to still be compatible with the big Qt. So if for some reason someone will decide to compile your application with a big Qt, and then those things from the compatibility folder provides alternative implementation for the big Qt for the types that are exclusive for Qt for MCUs. So by using this compatibility module, you can still keep compatibility for the Qt for MCUs specific things with the big Qt. Basically, that contains implementation for those types that are not available in the QML of the big Qt. Hopefully, I answered the question and the thing that was problematic for you. Just let me know if there are any questions still. Well, so let's get back to getting through the directories. Well, I stopped on the examples. So, well, in the examples, you have the source code for examples, of course, and these are the examples of some particular features that you can use in Qt for MCUs. The include directory, of course, contains some headers needed for compilation. Kits contains the configuration files for Qt Creator, and those are to define compiler, to define the SDK directories and so on for the boards you have installed. So Qt Creator tool is using those kits to to create default targets to compile your apps through the Qt Creator tool. Lib directory contains precompiled libraries with Qt frames use and parts of it. So for example, let's find something for Renesas board we are using on this training. There was RH50, but oh well, yeah. So not this one, this one. For example, here you have the PNG decoder library for the RA6M3G for the bare metal, compiled with the ARM GCC. And if you are going to look further, you have the null library for it. So it provides just an empty implementation if you're not going to use PNG decoding. And so on, so on. There is also a platform library, there is controls library, and all of the parts that are used in Qt for MCUs are located in precompiled binaries there. Of course, if you are going to buy the whole ultimate product, you will receive the sources for the whole Qt for MCUs. So there is also a way to compile it by yourself, not just by using the libraries, but by default, it comes with precompiled libraries that are completely enough to start loading your things. The platform contains some platform-specific configurations for those platform interfaces, those platform parts, the implementation for handling the rendering on the GPU and so on. Some CMake configurations with the flags are located directly in the sorry, this is for the NXP, for the Renesas. This contains all the CMake configurations. This contains the whole platform engine for each board you have installed, and it's still possible to compile the platform library by yourself to make some changes. For example, if you are going to change the screen, you will just have to modify some parts of those to use different screen, and that will be completely enough. Well, plugins are plugins for the Qt Creator and for Qt Design Studio. So if you will need some support for Qt for MCUs in Qt Creator, and Qt Creator by default will use this directory to search for the plugins, and then it will be installed on your device and in your tool. Well, it's just to hold those things there. And the source contains some well, application level reference implementations for some, generally speaking, usual cases. So for example, default main implementations that can be used to speed up your project start, some configuration for the FreeRTOS, some mains for the bare metal and the FreeRTOS as well, some third-party things like the fonts or some monotype parts. And well, this is shortly about what is installed in Qt with Qt for MCUs. And right now, I think we can go to the next slide. And I mentioned that a few times that there is something like desktop backend, and this is based on the Big Qt. So this is kind of a platform which implements the host backend to render your Qt for MCUs application directly on the host device. And this is especially needed to, well, maybe not needed, but especially useful to verify your application on the host and to not waste time to flash your device each time you will make any changes to your app. You probably know that flashing a device, it's rather a heavy task and it's time consuming. If you have a small app, for example, the Hello World one, it will be probably the few seconds, but once your app will become bigger and bigger, it will be a while to transfer your application to the device. And to avoid losing too much time for that, there is a desktop backend that provides you a way to test your things on the host machine. I also said that before, but just for convenience, I will repeat that. All needed Qt libraries that are for running desktop backend are delivered together with Qt for MCUs, so you don't have to install the big Qt and you don't have to have a license for it. MSVC compiler is used to compile desktop backend, so that's why Visual Studio is needed. But as I said, we are planning to provide MinWG compiler support, so then you don't need to have Visual Studio. All right, and we are slowly approaching the first live coding session, and let's see what you will learn during this live coding session. So for sure, you will see how to set up the CMake project from scratch. So from the empty file to some minimal subset of things that will allow you and enable you to build your app for Qt for MCUs. And of course, you will learn how to build that app using the command line. So with the most basic approach, and to run your app for both desktop and for the target. And so, well, let me set up things for you. Of course, we'll need some command line, and this is it. I will be using the commander, but it still can be a normal command line from the Windows. It's just a different terminal. You can use any that fits for you. And well, let's review the directory. So I have a special directory for this training. I will be keeping all of the files in this one. So just to have separate for our first application, I will create that. So mkdir first app. Let's go inside. Right now we will need some QML file to define our application UI. I will use Visual Studio Code for it. So just run code with main.qml and enter. Okay, here it is. So our empty file. Let's add something to define anything that we'll be able to identify. So for sure, import Qt quick. .15 and then rectangle. Let's give it some color. And it will be magenta. All right, I'm saving the file. And let's leave it as it is for now. And let's focus on providing CMake support. So once again, I'm getting back to terminal. And I will open a new file with a Visual Studio Code once more. And this time it will be CMake lists.txt. All right, and we have that one opened in the Visual Studio Code as well. Sorry, I need some water. I'm slowly losing my voice during all of those trainings. Regarding the CMake, we will need CMake minimum required version, minimum required version, and 3.15. We need to define the project for our application, and once again we will use the raw no-print project. Those two functions are the functions available directly from CMake, so this is nothing Qt for MCUs related yet. We are just setting up the things first. Up language is C++. And right now, let's start to use Qt4MCUs APIs from CMake. So we need the QL package, the Qt4MCUs package that will be visible for our CMake. And to do so, let's find package. And Qt4MCUs in CMake is called QL. All right. And right now we will start to use Qt4MCU specific CMake macros, and I will explain all of those one by one. So first one is to add the target. So this macro is covering the original target macro from CMake, and this provides a way to define the target, of course. And the most important thing that this macro is also supporting the kind of a way to compile your app to static library if you are going to link your application on some other last steps, some other more advanced steps of your product build process. But we are using the most simple way of it, so we are just passing the project here, and we are setting up the target. We need to add our QML file somehow to our project. So there is a special function for adding QML files, QL target. Just please no worry if you are not getting those CMake APIs. We will go through all of them in the later steps of the training. Right now it's just an example in live coding. QL target QML sources. First, and we have only main.qml. All right, and you can wonder because right now we are using just the main.qml file, and we are using the C++ language. So normally you will need the main function somewhere, and you can of course write that yourself, and you can run Qt4MCUs from there. But it comes with a default implementation as well. And if on the early steps of your application, you don't need anything specific in your custom, well, you don't need custom main function, then you can use one of the delivered together with Qt4MCUs. And to use that, then you just have to type up target default entry point, and you are going to use that for first up, and we have to tell which QML will be our root QML, and in our case it's a main, and you are just selecting it by selecting one of your QML files without extension. Right, and probably you can see that the first two macros were starting with QL, and the last one is starting with up, and that's not a mistake. All of the QL starting macros are the macros that are in general needed by our Qt4MCUs application CMake project, and those with up are just optional things and that can be skipped, and then you can provide your own implementation for some things that those app macros are providing. In this case, it's, for example, the main function. So as I said, you can still remove that one and provide your own, but just to keep it simple, we are using the one that is already prepared. And let's save the file, and we are right now we'll try to build our application. Let's review what do we have there. So there are two files, main.qml and the CMake list.txt, and we are just about to build it. And before that, we need to set up the environment. And first thing will be to set some environment variables. And first one will be ql underscore dir. And let's point that to Qt for MCUs installation. So drive C, Qt MCUs, and the version. All right. We will need also some tools, and to use those, we need to add those tools, maybe directories with binaries of those tools to the path environment variable to make those visible for us. So set path, and please remember to preserve previous path content. All right. And we have to find CMake, and it's located in drive C, Qt tools, CMake, bin. All right. Let's verify. It works. Well, and that should be enough. Let's create a directory. Build desktop. Let's go inside. And right now, let's generate CMake targets for our desktop. So CMake, for the parent directory, we have to provide the platform, Qt platform, and platform for host is just a Qt, as it uses big Qt under the hood, so it's Qt. And let's select the architecture for it. And we have that generated. Let's try to build. So CMake, let's build this directory. So -- build this directory. So dot and then 2 dashes target first up, and then config to build release. And the build process has finished with success. So we can try to run our application. It's located in the release directory, and its name is just first app.exe. And as you can see, it does not work. And that's an expected thing. And as I said before, Qt for MCUs comes with the libraries that you need to run your application on the host machine. So right now, I'm just going to extend our path with a directory of the libraries that are needed there. So set path, it's the normal way of doing that on the Windows. I'm preserving the previous path, and I will use the qldir /bin. All right, and let's try to run it once again. And as you can see, we have exactly the thing we defined in QML files. So we have the rectangle of the magenta color. So we are able to compile and run our Qt for MCUs application directly on the host machine. And right now, let's focus on building that for the target board. So let's get back to the application directory, and let's create another build directory, but this time for the Renesas board. Make directory, build Renesas. Let's go inside. All right, and besides those environment variables that we already have defined, we will need some more to cover Renesas board, and this will be for sure the environment variable for compiler. This is ARM GCC dir, and it's also delivered together with Qt for MCUs installation, and it's located in the C, in my case, in C drive Qt tools, Qt MCUs, ARM GCC 8. Okay, and we will need Ninja to use it with our CMake. So let's extend the path once again by preserving the previous content, and then Qt tools, Ninja. Let's verify Ninja. It works. Perfect. Well, the last thing to do is just to generate the targets. So CMake for the parent directory as previously. And there's the first difference, Qt platform won't be Qt anymore, and it will be ek-or a 6M3G dash bare metal to indicate which operating system or no operating system we'll be using. Then let's define the release build, CMake build type, release, and let's tell our CMake which compiler we will be using. So we will provide a toolchain file, which is also delivered together with Qt for MCUs, CMake toolchain file, you'll dir, and let's right now type that long path. So lib CMake you'll toolchain, and then ARM GCC .CMake. Last thing to pass Ninja as a generator. So let's try if that works. All right, so we have targets generated, and let's use Ninja to build our application. Ninja first up, and the build process is ongoing, as you can see. Linking process, and that's it. Some short summary of used data, and well, you can wonder how to transfer that application to the board. So Qt for MCUs comes by default with flash targets. It's done for each executable added to compile with Qt for MCUs, and it works by just well, it works that way. So you are just running CMake target that starts with flash underscore and then name of your application. And this will trigger internally the vendor tools to flash the device with just that one short single command. And right now I will show you what's currently on my device by just switching the presentation to content from secondary camera. So as you can see, this is my Renesas board, which is right now just showing the empty black rectangle. And we are going to flash our magenta rectangle to it. So right now I'm just starting the flash command. And that's it. Well, probably you cannot see the exact magenta color there, as the camera is, well, rather a low quality one. So, well, please trust me. This is a magenta color on the screen, but it's the flashing of the device. It's simple as this. So let's get back to sharing my screen, and just to show you how this looks like. So as you can see, Qt for MCUs flash target has used some JLink tool to connect to the device and flash the program to the board. All right. So this is about compiling your application in command line for both desktop and for the board. So this is the summary of it. Well, let's once again go through this. So you are creating this specific directory for your application, then you are setting some, of course, you're creating some files, QML files and the CMake list.txt. You are setting the environment variables, and the most important one, the QLDIR. You are generating the targets for your Qt4MCUs application by using a CMake, and you are building it with a default CMake style, or you can use generator for it, like we used Ninja for the board. Well, and that will be the only thing needed to compile and run your app. And do not forget to provide the directory with QLDIR binaries to let the operating system know where those missing libraries are located. And right now there is a time to go through rest of the QML, rest of the CMake APIs from Qt4MCUs. Some of them are those we have already used in the live coding session. But most likely the rest of them are something new for you. So still it could be an interesting part. So to configure your platform during the target generation, you are using Qt platform, of course, we use that. And for desktop platform, it's just a Qt and it's the default one. So you can not provide that one, that thing for the host. And of course, it can be one of the boards that Qt4MCUs supports by default. Some Renesas boards, for example, RH850 or the one that I am using right now. Possibly the other vendors are also selected by modifying this variable. Qt color depth is used to define well, display color and to define the frame buffer format. So this should be one of the 8, 16, 24, or 32 values, as this defines the bits per pixel for our frame buffer. And by just lowering the value, you will allocate the less memory for the frame buffer, but you will also decrease the quality of it. And for the platforms that are using it with the layers, with the hardware graphical layers, this value means the default one. So you, for each layer, then you can define in the QML code a different color depth. QL add target is for adding, of course, executable target to CMake, and that comes together with some other features as well. So you can provide a static library optional argument to compile your application as a static library. And this could be especially useful if you are going to use your application as a library together with other components of your whole product. As we know that not in all cases you just can simply write the application, well, run the Qt4MCUs one. So if you are going to use it as a module in your whole product, it's still possible by using a static library argument. And the short example below that you are defining the target example app with two sources that are not the QML sources, but just the C++ source code or the C. To add the QML files, we are using Qt target QML sources. We also use that one in the first live coding session. So it takes the target, of course, for which one we are adding the files. Then there is a list of the QML files. And of course, we can pass some optional arguments like output directory to tell where the intermediate artifacts should be located. We can use the module URI, but this is the deprecated API that was an old way of creating QML modules. So you can still use it, but you shouldn't really. Copy QML files will mean that all the QML files that you provided in the list of the files will be copied to output directory as well. And that could be useful if you are building more complex solutions. Then some optional macros. So there is an app target default entry point, which follows the operating system that you have chosen and provides default main for your application. So if you are going to use the bare metal, it will be just a main function with initializing the root item that is based on one of your QML files, and then there is a short initialization of the QL that by just calling few functions, and finally running the endless loop with our rendering loop. And app target setup OS just well, setting up the things needed to run operating system. So if you are going to use FreeRTOS reference implementation, you'll probably need to run this macro to connect some initialization and the parts of Qt for MCUs that are normally not included there. This is to add the system-specific things. And the new way of doing the QML modules is to use add QML module, which will compile your QML files to separate static library. And well, let's go through the arguments. So of course, target URI to define the URI then used to import your module in other QML files. Of course, list of QML files, some headers for example, interfaces if there are any, some sources like C++ files, the imports that are used by your module, and of course, output directory for redirecting the artifacts from compilation. Ql add resource is for adding images. So this macro will be used for adding any PNG, JPEG, and so on files to your project. There are also a prefix and a base. So the prefix will mean that all of the assets paths will require prefix in your QML to access those files in the image component, for example. And the base path is to shorten the path of your files. For example, if you have in your project assets located in some, well, let's say complex and long directory, you can shorten that requirement of passing the whole path in your QML files by providing a general common base that will be added internally in our Qt for MCUs engine, and you will not have to provide that path in QML files. And of course, output directory to redirect all the artifacts to a different place. For translations, we have Qt target embed translations, which, well, defines the translations and compiles in translation files in the binary form to your application. And to integrate your app with C++, you have the special macro to generate interfaces based on the C++ headers, and it takes the target, of course, the headers, and then the output directory, as always, to redirect the artifacts from the compilation process, well, and possibly the QML imports. Some APIs related to fonts. So Ql fonts dir will define where your fonts are located. Your custom fonts, by default, this value points to installation directory, source, third-party fonts, and there are default Deja Vu Sans fonts delivered. And there's also a Ql default font family to avoid providing the custom font family for all text and static text components. You can define it globally to use it in all text and static text components with just one line. There is also the texture cache concept. So something that is used for various things, to be honest. So if you are going, for example, to keep your all of your images assets on the flash memory, but for some reason, for faster access, you will need to move them to the RAM memory during the runtime, they will end up in texture cache. And the same will go for the compressed images. So all compressed images normally are staying in the place that that you would like to stay them. And once they are decompressed, they are going to texture cache. And this is super important thing that if you are going to use that compressed images, you have to set the value of this variable, this cool texture cache, to at least size of the biggest decompressed image. So sorry, someone has connected to my Jabra, so I have to disconnect that one. I hope you still can hear me. Well, so as I said, you have to set this value to at least the biggest decompressed image. So size width and bits per pixel plus the eventual padding of the alignment is the minimum size of your texture cache to fit at least one image, one biggest image in your texture cache. And setting it to the too low value can cause your application to stop working, and to big value can even cause a malfunction, as you can overlap other parts of your application, for example, heap or the stack memory regions. And that's probably not what you would like to do. Well, so just to remember that this is a really important API, but it has to be used with a special care to not make any problems. There are some additional CMake options to, for example, for debugging. So you can enable the bytecode by just defining cool debug bytecode, and this enables JavaScript bytecode generation, and then it will be generated as a comment to the right side of the artifacts files. And then there is also a cool debug line directives macro variable that allows you to enable generating the line directives that will point back to the QML source. And well, because all of the QML files are converted to the C++ during the compilation process, so your debugger will then know in which place in your QML file you should search for potential problems if you are debugging your application. Well, this was about the CMake APIs that are used to define your project, but right now I would like to focus on the overall build process that is a rather complex thing of the whole Qt for MCUs application. And let's focus on the left side, and I will go from top to the bottom by explaining all of the processes that are happening during the compilation process. So for sure, the input thing for whole compilation is the CMake list.txt file that defines your CMake project, defines your assets, fonts, and so on. So this is the definition of all of the things that will happen in the next steps. But well, let's be honest, all of the applications have assets, have fonts, have some logic behind this. So almost every application will follow all of the steps that are there. And the first thing in the compilation process is to compile your assets. So any PNG, JPEG, or any other images will go through the tool called QRCC. This tool is converting your PNG and other files to the formats that are known for Qt for MCUs. And normally, by default, all images are going to be a bitmaps on the Qt for MCUs side. And as an output, this tool produces the C++ files with normal row arrays of the bytes that are then interpreted as a particular format of the image. If you are going to use those images compressed, QRCC will do a recompression to the format and the compression known to Qt for MCUs, and then those arrays will be smaller things, but still some processing on those input files will be done to produce your artifacts and some intermediate code for application. The next step is to compile the fonts, and the tool QL font compiler is doing that. And what it exactly does? So it generates glyphs for your fonts. So if you are using some text elements, it will produce the glyphs for the letters and for the characters that you are actually using in your QML files. So it will produce only the range of the glyphs that is used in your app. Of course, you can extend that range, but this we will be talking later on. Well, and those glyphs will also be a bitmaps. This will be a different format. This will be alpha maps, so it will consume less memory than normal images. But still, it's important to know that the font compiler will produce the glyphs for each font type and size exclusively. So if you have the same font but different sizes in two different components, your glyphs will be generated twice. So you will consume the memory for the glyphs twice with different sizes. And it's also producing the artifact as in C++ file. After assets generation, so after converting the images, after generating the glyphs for fonts, there is a time to generate interfaces. For example, if you're going to connect your QML interface definition with C++ parts, so this is a part that takes care of it. So you have some input header files for your interfaces from the C++, and QL interface generator is converting those headers to QML representation to let the next tool know how to integrate your C++ logic together with the QML logic. So directly going to the next step and to compilation of the QML files, which means converting those to C++ implementation. And each QML file in Qt for MCUs is in fact converted to the C++ representation, and we are picking all QML files from your application and those from the previous step, and we are producing C++ representation of all of those. So if you are initializing any component like text, like your custom component, your, I don't know, rectangle, it will be converted to the C++ rectangle class, your C++ button class, and so on, and all of those things will be put into the C++ files, which are next artifacts for our whole compilation process. And finally, C++ compiler will take your own C++ files. Possibly this could be, of course, the C compiler as well, and will take all of the artifacts that are created during the compilation process, and will compile them all together and then link together with the libraries delivered with Qt for MCUs. And for sure, those will be at least QL Quick Ultralight and QL Platform Abstraction, and those two are the absolute minimum to run the Qt for MCUs application. But possibly you can use all other libraries for example, controls, PNG decoding, and so on. And after linking process, we have our binary ready. So this is quite a complex thing. So if you have any question to any part of this compilation process, please feel free to ask. I will try to answer that more clearly. But well, if any question will appear, I of course will answer this. But let me go to the next slide, which is about the QRCC itself. So this is about the tool that is to compile the images. As I said, it converts all of the images to C++ representation, to the bitmaps that are stored in the normal arrays. And this tool as well follows some desired resource loading policy. So if you are going to keep your file on flash or copy to RAM on the startup and well, whatnot, this tool will mark those arrays in the proper way to make sure that the platform will do exactly what's expected to do with those. It could also do some optimization for graphical transformation. It could mark some files that those will be transformed or rotated to gain some performance boost on this. It could compress the images if you are going to use those in compressed format. And well, the also important thing is that semi-transparent images can be optimized by this tool. And it's quite a great feature of Kit for MCUs. So for example, let's imagine you have the image that is that contains some borders or some accents for parts of your application, and most of that image is the completely empty space with fully transparent pixels. And this tool is able to split that image to separate parts of it, and then it can get rid of data that is well, just empty and not visible for the final user in the application. And by doing this, it can save really a lot of memory just for assets compilation. Well, yeah. So the next tool is QL font compiler, and this tool generates glyphs that are also stored in the byte arrays as pre-rendered alpha maps. I also said that it defines and generates glyphs for each font size combination. So more fonts and more sizes, different sizes of the fonts in your app will mean more glyphs generated and more memory consumed for those. And glyphs are automatically selected and generated for text that is in your QML files. And as I said, it can be overridden by defining the ranges of additional glyphs you are supposed to use in your application. So it's completely fine to provide additional set of the glyphs that you're expecting to use in your app. Well, yeah, that's it about this tool. And to generate QML interfaces to your C++ classes, you will use QML interface generator tool that converts your headers to QML representation, which is then used by other tools to properly understand what is the logic behind this and how to connect those things together. And this tool forwards the properties, signals, and the functions from your class to the QML. So this will mean you will be able to use the normal C++ function and run it from the QML code. And that's a pretty good feature. And the same goes for the members of the class that could be properties or the signals. And the QML to CPP, it's the tool to convert the QML files to C++ representation. And it's done for each QML file. It also defines how to initialize those components on the C++ side. But well, it's completely transparent for you. It's something that is done, well, it's hidden, but it's important to know how it works. And this is about the first part of our training. And right now there is a time for a short coffee break. So if you have any questions to the parts that we covered during the first steps, well, then please ask. And if not, I will just start the timer for you to make sure that we have the same hour everywhere. All right, I don't see any questions, so I'm starting the timer, and let's see each other in 15 minutes. A bit more rest right now. So with the batteries charged, we are starting to cover the Qt Creator configuration. So this will be the tool that we will be using for the rest of this training. And as I said, Qt Creator is a default tool and the recommended one for working with Qt for MCUs. We will go through a few steps of configuring it. So as the first thing, we'll go through checking if Qt for MCUs plugin is enabled at all in our Qt Creator installation. Then we'll verify what devices we have installed, and we'll verify if kits that defines how to build your app are properly defined also on your side. So right now, let me open Qt Creator. It's opening on my side, so please give me a moment for this. It is still opening. Okay, here it is. Don't show those notifications, and well, let's verify the version of it. So help about Qt Creator, and we have a proper one, so 4.15. You should have the same. Okay, let's verify the plugins. So once again, help about plugins, and let's search for MCU. You should have the same, so there should be a device support tab with MCU support under it. It should be loaded, so the tick under load should be also checked. All right, and all of those things are by default, so you really shouldn't modify anything. All right, so let's verify the devices that we have installed. So tools, options. All right, and let's scroll down the left side to devices, and let's switch to MCU tab, in which we can verify the installation. So you should have the Qt for MCUs directory there, and there should be also a green tick which verifies if regarding this path, in this path, it can find the QML to CPP tool, and on my side it was found, so the path is verified properly. And below you can find list of your installed targets, and you should have at least desktop, and optionally, if you are going to follow these live coding sessions also on the device, you have to install the RA6M3G bare metal from the Renesas. And let's verify the Renesas board. So I picked that one from the drop-down list. We have the ARM compiler from GCC, and SDK is not needed right now as we are using precompiled binaries. All right, and let's verify in the kits. So left side and scroll up. It's the first thing in the list. Let's search for desktop, and let's verify the CMake version because normally by default Qt Creator will pick the system one, and that won't work. So we just have to verify that CMake tool is the one that is delivered together with Qt. So CMake 3.19, and the same for our Renesas board. Let's verify if the CMake is set properly. So instead of setting system CMake, let's pick the one marked with Qt. All right, let's click apply. Okay, and that should be enough. And let's try to verify that with some Hello World application. I will create a new project, application Qt for MCU, MCU support application, click choose. Let's give it some name, Hello World. And let's change the location to our training directory. All right. Just disable the things that are selected by default. I had the WebAssembly, but just verify if any of desktop targets and kits are not selected, and then you can go and select desktop and select your board. In my case, Renesas board. And let's click finish. Okay, so on the left side, we have our project structure with the CMake list txt file. We have some simple QML file with hello world. So this is a rectangle of a given size, and by default, it will be white rectangle. And there is also a text which is centered on the screen. It has a salmon color and displays hello world string with a pixel size, font pixel size 14. And let's verify that one on the desktop. So on the left bottom side of Qt Creator, there is an icon of microcontroller. Let's click on that one, select desktop, select release. Wait a bit to reconfigure the project, and let's just hit play. Well, brilliant. So our application has compiled successfully, and also it's running on our host machine. And let's verify that one as well for the device. Once again, let's click that icon of the microcontroller, and let's pick our A6M3G bare metal kit and release. We have to wait a bit. All right. And I will also just run our project, but before that, I will switch my view to camera that displays what is happening on the device. So right now, I'm starting the compilation of our project. Build process is ongoing, and shortly we'll have our Hello World application on a device. Yes, the flashing process is done, and you can see that we have exactly the same application on a Renesas board. So it's as simple as that. We just hit one button to transfer our application to the microcontroller. All right. Well, let's get back to presentation. And right now, there is a time to start developing our example demo, which will be the coffee maker machine. And what you will learn in this first live coding session, you will learn how to use built-in controls, so how to use buttons, sliders, and possibly other controls that comes together with the style library. You will learn how to interpret the compilation artifacts. So all of those tools that we were talking about before are in fact used transparently for you. So each tool is connected to your project internally, and the artifacts are created implicitly for you, but you will need and probably want to know how this works and how the compilation of artifacts affects your application binary size and how it works. So you will learn how to interpret those. And you will also learn how to use CMake interface to extend your application. Just to give you a knowledge what we are going to build. So this is the composed structure of our application. So we will have this splash screen on the left side with some logo and button to starting our application. Then we'll be showing simple coffee selection screen, which will have some icons of the coffees with labels. There will be also a second version of the logo. Some background is also shared together with all of those screens. We'll have two menus for switching the language and for history to see what was brewed before. And there will be coffee parameter screen to define how strong is the coffee and how much of it you want. Also, the temperature will be available. And there will be also a button to start brewing, and some small pop-up will show up to display the progress of the brewing. And well, all of those screens will demonstrate some features of Qt for MCUs and some basic approaches that are commonly used. You will learn how to use some QML components, how to style the controls, how to use controls, how to connect your application to the C++, and so on, step by step. And right now, let's try to focus on creating a first step in our application. But before that, I will share something with you, and I should do that at the beginning, but honestly, I forgot to do this, so I will need to find out the link just for it. Just a second. All right, and right now I'm just sharing with you a link to the training materials. It's available on chat for you. All right, and I will show you how this training materials will work. So you will receive exactly the same copy of the files I have here. And each of those subdirectories contains some steps. So this is the first application that I have built in the command line. So this is just a solution for it. And each of those coffee maker steps are exactly the steps I will be doing on the live coding sessions. So right now I will be starting from the one coffee maker step 0. And there are two subdirectories in each of the steps. The files will contain the files that are prepared to speed up the live coding process. This is the implementation of the things that are exactly the same as the things I will be showing you. So we won't repeat those steps that often. And the solution will contain the proper state after each step. So if you are lost for some reason in some live coding session, you can always get back to the one of those steps, go to solution, copy all of those things, and this will be exactly the state of our application after each live coding session I will be doing. So you can align at the end of each live coding session by just copying solution files from the particular directory. And well, this works for all other steps as well. All right. But on the beginning, we won't be using that so fast, so you will have still some time to download those. Okay, so I'm opening the Qt Creator once again. I'm closing the previous Hello World project. I'm going to welcome screen. And I'm creating a new project. Once again, application Qt for MCUs, MCU support application. I'm switching directory to our training directory. And I will call our application Coffee Maker. All right. Just make sure that you don't have selected any of the desktop or WebAssembly targets. Just please select desktop Qt for MCUs Qt for MCUs 1.8 desktop and Qt for MCUs 1.8 EK-RA6M3G bare metal. All right. Next, we are not using any version control, so just finish. And we have exactly the same default QML file as previously with a hello world. So we are going to modify this. The size is valid for our board, so let's leave it and let's modify that to get rid of that text component. And I will just use some color. And it will be brown for now. Okay, let's select desktop and release target. And let's try to run it just to verify that it simply works and we can start developing our application from there. All right, so here it is. Let's focus on the next steps. So as I said before, let me just show you that quickly. We will have the splash screen, and let's try to create a special component for our splash. So let's click right on the hammer icon near the name of our application. Click Add New. And let's pick Qt, QML file, Qt Quick 2. Let's call it splash.qml. And next. Finish. All right. So Qt Creator redirected us to CMake lists.txt file as it automatically does not update those files. We have to modify the CMake project by ourselves. So let's add the QML file to QL target QML sources. And it's just about adding that. So it should be this. Splash, okay, splash, this one. All right, it also appeared on the left side, so we can start modifying this file. And well, currently we have only import and the item. Also, the one important thing there is that import version is, well, it's needed by Qt Creator, but it's completely skipped by Qt for MCUs. So this version is just to prevent some error messages in Qt Creator, and it's used by default there. But in Qt for MCUs, it does not matter. It can be any version. It will be always skipped. All right. We would like to have some button and some logo there, but we still don't know how to add assets. So for the logo, I will create just a placeholder. And for the button, I will use the default button that comes with a control library that comes with Qt for MCUs. So let's import that controls library. Controls to the 0. All right. Let's save the file. And in the CMake list.txt, we have to link that library. And to do this, we just have to add target link libraries. And we are linking to Maker, QL, Quick ultralight, controls, style, default. All right. Okay. And so right now we have defined how to use the controls. So let's try to use those. So the item will need some ID. It's root in our case. We will define a signal to pass the event that someone has clicked the start button outside the splash control. Okay, and we need to define how to place our logo placeholder for now and the button. And I would like to have one under another. So I will use column to lay out those things in that way. And the column itself will be aligned to the parent in a special way. So I will define anchors for it. And from the top, it will be aligned to parent top. And I will give it some margin, top margin, 40 pixels, and horizontally, I will center it also to the parent horizontal center. Right, I will need some space between items in the column, so I will define spacing to 14 pixels, and the rectangle will be our placeholder for the logo. All right, let's give it some ID. Some size. And some color to make it different. Purple. All right. So we have placeholder for the logo, and we still need the button with an ID start button. The button itself has to be aligned to the logo in the same way. So has to be aligned to the center of the logo. So anchors, horizontal center. Let's align it to the logo horizontal center. All right, we need some content in the button, so just provide a text start and on clicked. On clicked, signal handler will just receive if the button has been clicked, of course, and we are going to expose this event outside the splash control. So we are about to call root clicked signal, and then we will be able to watch this clicked signal from the root outside the splash QML file, and we will be able to take some action on this. All right, so we defined how our splash screen will look like, and right now let's try to use it. So let's go to our coffeemaker.qml file, and right now you can just try to modify that with adding a splash. Well, let's give it some ID. Let it fill the whole screen. So anchors fill the parent. Normally, every control is visible by default, but we will be changing the property. So to indicate that the initial state is visible, I will provide this property explicitly there. And we are going to watch our signal with a signal handler on clicked. And if anyone will click our splash screen, I would like to hide it. So just set splash visible false. And that should be enough to run our application and verify if our splash screen is on the screen. And here it is. So as I said, we have a column there that is aligned to the top, and it's with a 40 pixels margin. Then there is a rectangle that is placeholder for our logo, some 14 pixels of spacing, and the button that should forward the event to coffeemaker.qml file. And we should hide the splash screen once I will click the start, and let's try this. It simply works. Let's verify that one also on a device. So let's go to bottom left side of the Qt Creator screen. Let's click that microcontroller icon and then select the target for the board, release. We have to wait a bit to reconfigure the project and then just hit play button. And I'm switching the view to secondary camera. We still have the hello world there, and shortly we will have our new application. It's flashing. All right, so the same application is finally on a device. I can try to verify if the start button works. Works perfectly. Okay, let's get back to the screen. Okay, so basically we right now know how to define a new component, how to use some of the properties inside and outside, and to speed up the things, we'll use those previously prepared files from training materials. And well, let's go to those. So one coffee maker, step 0, files. I'm selecting all of those without file list, copying those. Let's get back to our coffee maker directory, and in the root directory, let's paste all of those perfectly. And this is quite a lot of them, and we are going to add those to our project. So let's go to cmakelist.txt. Maybe let me verify those files. What did we copy at all? So we have some new font. We have some helper QML files. Those will provide some objects that will hold some spaces, margins, some colors and definitions for those, and other QML components that will define the components in exactly the same way as we did in splash.qml. But simply to save some time, we have already those prepared. All right, getting back to Qt Creator, let's open the cmakelist.txt file, and right now I will add those QML files. Back button, coffee parameters, coffee param group, coffee selection button, and the coffee param slider. Those are the new files that I have added. All right, they are also appearing on the left side. We would like to switch the font. And before adding the QML sources, I will define some properties. Set target properties for coffee maker. Properties tool default font family. It's Roboto. And another property to tell Qt for MCUs where those fonts are, set property target coffee maker append property to fonts here. And right now the $, open curly braces, and we'll use some reference to CMake directories, CMake current force dir and outside curly brackets /fonts. This will refer to the directory in which we have our application project, and then there is a fonts directory that will hold the Roboto font. All right. We have the helpers, as I said, and those are the singletons, and singletons has to be different static library in Qt for MCUs. So I will have to define a custom component for it. Ql add QML module. Let's call it helpers module. And then some arguments, URI, helpers, list of QML files. So QML underscore files, and let's provide the QMLs that are in this module, helpers, team.qml and helpers. Helper functions.qml, and the output directory. Once again, $, open the curly braces and cmake current binary dir / helpers module, and let's pass generate QML tabs. Save the file, and Qt Creator will be happy if we will provide additional path for fonts for it. So just to make it happy, without Qt Creator, it's not needed. Ql import path, QML import path, $, and once again curly braces, cmake current binary dir outside the braces, helpers module, hash of empty string. Okay. It's quite a lot of this. And last thing to do is to link our application with the module, with the helpers. So in the target link libraries macro, I'm adding helpers module. All right. So let's switch to desktop once again, and let's verify what changed. Hit the play button. All right, so our application has built successfully. So we did all the things in cmake list.txt properly. And let's verify start, and application is exactly the same as previously. And right now we will try to use those prepared components. So let's open coffeemaker.qml. And this is exactly the same file as previously. And right now let's try to add some more content. We will try to provide the functionality of selecting a coffee. So once splash screen is hidden, we will try to show the coffee selection screen. There is a new component, coffee selection. Let's give it some ID. Coffee selection. Let it also fill the whole screen. So fill parent. And by default, it will be visible false. So right now, we would like to show this screen once splash screen is hidden. So in the same on-click on the signal handler from the splash, let's reference coffee selection and visible true. Okay. Let's try to run it. All right, so the same splash, and let's click. We have the new well, let's say pretty screen with selection for the coffees, but nothing more is happening to those. We have some texts, we have some placeholders for the images, but right now there is nothing more. Let's close this and let's try to add another screen to provide a way to configure your coffee once it's selected and to have some place to redirect the user after he select the coffee. So there is another component, coffee parameters. Once again, ID. Params. It's also invisible by default. Let it also fill the whole screen. Okay. And okay, so we have that screen already, and this screen will have functionality to go back to the previous screen, and it's done by forwarding the signal, which we can watch, and it's signal back. So signal handler will be called on back. And then there is a coffee params. Coffee params should become invisible again. So false. And coffee selection should be visible. So true. All right. And well, we should make it somehow possible to enter this screen. So once coffee is selected, we would like to open the coffee parameters, and coffee selection screen has also a signal for it, and it's called coffee selected. So signal handler is of course called on coffee selected. And if anyone will pick the coffee, we would like to for sure save the index of the coffee that is selected. So coffee params has some property for it, which is called coffee index, and the coffee selection screen has also a coffee index property. So we will just reference this and forward it to coffee params screen. And right now let's focus on switching the screens itself. So coffee params visible. Of course, it will become visible, and coffee selection will hide. Visible. All right, let's try to run it. All right, so splash screen start, and so let's try to pick some coffee, latte macchiato, and we have the new coffee parameters screen. Well, the skeleton for it ready, but the start button is not doing anything right now. We can just verify the back button works. All right, let's pick the cappuccino, and on the right side, we can verify that we are also passing the index properly. The same for espresso. Right, perfect, and we can verify that on the device. So let's switch the kit on the left bottom side. Let's click play, and I'm switching the view to secondary camera. All right, this is still the old content, and shortly our application will flash to the device. Okay, the flashing process started. And here it is. So I'm clicking just start. We have our new screen on the device. We can select one of the coffees. Let's pick Cafe Mocha. And here it is. The parameters screen is also there. And we can verify that sliders are working as well. Start button is still not functional. Let's get back. Let's try to open Cafe Latte. Here it is. We can open cappuccino as well. And the string in the top corner is switching as well here. All right. I'm getting back to the sharing screen. And let's open the Qt Creator perfectly. And right now, I would like to verify the artifacts and what things were generated during the compilation process for Qt for MCUs application. And to explain that for you, I will open the Visual Studio Code and our training directory. All right. This is not needed. All right. So let's verify what do we have in the training directory. So our Hello World application was there, first application, training materials, and Coffee Maker, which is the most important one. But we won't go in there because build artifacts are held in the separate build directories. And let's pick the one for the Renesas board. So build Coffee Maker for the Renesas, and then CMake files and coffeemaker.dir. All right. And let's try to find out what's there. So as you remember, we created by ourselves the splash.qml file. And let's search for the splash. It's there. I will also open the splash screen in Qt Creator. So what's in our splash.h, which was generated? So let's see that in the root of splash.qml, we have an item, and it's the struct that is inheriting from the item as well. We have some properties that are exactly the same things as we exposed from our splash.qml. So there is a signal called clicked, and that signal is also exposed as a struct public field of a Q signal template type with a given function declaration. So as I said before, all QML files are converted to C++ representation. In this case, it's the struct with some properties and some other parts of our interface, like for example logo, which is the placeholder for the rectangle, for the image, which is the rectangle. The start button is also initialized there. And we can also look on the C++ side, all of the initialization and property setting is also converted to the C++ version. So for example, the spacing 14 is set as just calling one function in the C++, but this is all done implicitly for you. So you don't have to care about this. You just have to know that it works that way. Let's see some other file, for example, coffeemaker.cpp. This is exactly the same thing for it as for the splash.qml. So coffeemaker.qml has been converted to C++ version, and all of the components used there are also in this C++ file, and you can find the reference to those to the lines directives that are generated as comments. And the last thing I would like to cover regarding the artifacts for now is to see Qt font engines. And this is something I was also telling you about previously when I was reviewing the tools and the build process. All of the texts are held in alpha maps in our artifacts, and here you can find the here you can find the alpha maps for the fonts for the Roboto of size 19, for example. And if you will scroll down a bit, there is a Roboto of the size of the font size 20 for particular glyphs that were auto-generated. All right. And well, this is about the first live coding session. And right now there is a time for the lunch break, which will take 1 hour. And the question to you, if you have any more questions or anything what is not clear after this first session, you can use the Q&A section or the chat to ask about the particular things that are interesting for you. I will try to answer those still before going to the lunch break. All right, if not, I'm just starting the timer for 1 hour. So here it is, and see each other in 1 hour after the lunch break. All right, good morning, everyone, after the lunch break. Let me get back to presentation. Hopefully, I have all of you back. So the next topic is the asset management, which will tell us how to add and how to manage resources. So images in our application, how to add those. And the first API is QL add resource, the CMake macro, which takes the CMake target and then the list of the files that you would like to add. And then there are two properties, two optional arguments, prefix and the base. And those are to manipulate how you're referencing your files from the QML. And finally, the output directory to redirect your artifacts from the build process to different place. And let's focus on some examples of those and how the base and the prefix works. So here you have the example of using QL add resource with target my app, and you are adding the file which is located in the res subdirectory, and the file is named image1.png, and we are providing an optional argument base which is res. And by doing this that way, we are getting rid of this res directory while referencing that on the QML side. And below you can see that we can then just reference the image without that subdirectory, which is provided in base. And the prefix is the opposite side. So if you are for some reason going to add the additional an artificial thing to your path, you can extend it with the prefix, and then you will be forced to use that prefix to all of your image paths. And those can be used in the same moment. And this, so in combination of those will look like base is always cutting our path and prefix is always extending our path. And those mechanisms could be useful for providing different assets, for example, for different resolutions of the screen, when you can have, for example, different directories for different resolutions. And by just switching a base argument, you can decide which images are loaded to your app. On each of the files from the assets, you can provide properties. So for example, you can set the QL compression, which will mean that an image will be stored in your memory in compressed format. Then it has to be decompressed in the runtime, so it will be a bit slower, but it will consume less memory in your binary and in your flash. So depends on what is your need. You can decide to use the compressed format. QL copy to RAM will mean that an image will be copied to the RAM memory during the startup, and this will give you the additional this will give you the fast access to that file, as the RAM memories are usually much faster than the flash, and this can improve the performance if you are looking for some additional FPS. QL image color depth is defining the storage bits per pixel depth of particular image. So you can control how big is the image in your binary, but just keep in mind that lowering the value from the default one will cause the quality loss. So images with 16 bits per pixel color depth will look worse than 32 bits per pixel ones. But well, if you have the screen that is low quality, you can still lower the quality of the image, as having it in a bigger one will not give you additional quality at all. So this is to control to which color depth image is converted then during the compilation process. And QL optimize for rotation and optimize for scale are two flags that will cause passing those informations to the platform, and the platform can decide how to optimize for rotation and for scale. So for example, if your platform has some super fast memory, you can move your assets that are for rotation or the scale to that memory to get the super fast access, as probably during the transformation you will manipulate a lot with the pixels of that image. And those flags are for this. All of those have also a default equivalence. So if you are setting one of those, you are just telling Qt for MCUs that by default, I would like to have compression on all of the images, or I would like all images to be copied to RAM and so on. Still, if we are using the default, you are just defining the default state. And you can override this by providing the specific parameter for particular files. So if you have, in this example, Qt default compression set to on, it will mean all of the images will be stored in the compressed format. But if you are going to use one of those images you have still as a normal bitmap, you can disable that for a single file. And we had live coding there. Well, we'll see how to add resources to your app, how to change file attributes, and we will analyze what is the outcome of the compilation process and what resource compiler, so the Qt RCC tool, is doing for us and how the output looks like. All right, so let me just prepare for it. I'm opening the Qt Creator, and I'm starting from the point we finished last time, and still a bit of setup from my side. All right, so let's get back to the training materials. So if any one of you is following the live coding sessions with me, so I have currently the state, which is an equivalent of solution from step 0. And right now we are going to implement step 1. And before we start, let's copy some files that are needed for this live coding session. Let's review quickly then. So there are some updates for the helpers. There is a directory with resources. So as you can see, I have some, I have prepared some images for the back button, some icons for coffees, 2 versions of logo, background. So we will try to add those to our app, and some updates to already existing coffee parameters and coffee selection. Sorry, I copied all of those, and I'm going to our application directory, and I'm pasting all of those. Replace the files if that's needed. And right now, let's get back to Qt Creator. All right. And as always, I will start from adding the things to CMake project. And after the Qt add target, so where do we have that? Here it is. So here I will add our resources. Qt add resource coffee maker, and we are providing files for this. Resources button back normal. I will copy these resources to speed up the typing. Back down. Big. One go small. Background. Cafe latte. Cappuccino, espresso. Ristretto. Latte macchiato.png. And we are going to use our API for shortening the paths. So as a base, I will just pass resources. All right. Configuring failed, so probably I did some typo. File provided to files not exist. Cappuccino is wrong. Cappuccino. All right. Right now should be okay. Perfect. Well, so let's try to modify our application to provide the new images on our app. So the first thing will be to replace the rectangle with the color with some image to provide some gradient. So we won't no longer need the rectangle. So to avoid some redrawing of it, I will just replace it with item. Item, of course, does not have the color property, so let's remove it. And I will provide an image as a background, which of course will fill all the screen. Fill parent. And source for it is of course QRC main bg.png. Save. All right, so let's try on desktop, release. Wait a bit for reconfiguring and let's hit the start button. And as you can see, our brown rectangle is right now replaced with that nice gradient. Let's start, and of course, here's an update for our previously existing screen. So we have a coffee logo, small logo there, and there is no logo. Still, buttons are not working there, but we don't have the logo on this splash screen, and we don't have icons there. So in the next steps, we are going to update those. Let's focus on our splash screen. So here we have still a rectangle for our logo, and we are going to replace it with an image and an asset that is prepared for that. So I'm replacing the rectangle with an image. Width and height are delivered together with an asset, so I'm not going to change those. Image will have their own properly set. The color is also not existing thing in the image, so we just have to provide a source, which is a QRC logo big.png. Save the file and let's try. And right now we have a nice logo set in exactly the same place as previously we had our placeholder. Start, nothing changed there, and we can verify that on device. I'm hitting the play and I'm switching the view, of course, to secondary camera. Still, we can see the previously compiled application. So this is still an old content. And right now we have to wait a bit for application to be compiled and flashed. Okay, right now the board is flashing, and the flashing will take a bit longer than previously, as we have to flash our assets as well. So our binary application is a bit bigger than previously. And here it is. So without any changes, just by changing the compiler and the toolchain, we are able to transfer our app to the device. Yeah. So let's get back to sharing the screen. Just to remind you, if you have still any questions, please feel free to use Q&A section. I will try to answer all of those directly during the training. All right, so right now we updated some backgrounds, logo, and the main missing thing right now are the icons of our coffees. So let's try to understand how the colors are drawn. So let's go to coffee selection screen and let's see what do we have there. So there is a row with a repeater which then repeats the column 3 times, and that column has a definition with a selection button. So each coffee selection icon is in fact the coffee selection button, and let's see what's inside there. And there is a rectangle that holds currently the color based on the index of the coffee, and the color is retrieved from the helper functions, and we are going to provide the similar function but for retrieving the image. And right now I'm going to helpers module on the left side. Let's expand that one, and I'm going to helper functions. Let's find that function which provides the color. Here it is. Get coffee selection button color. I will copy all of this and I will provide some modification. So we still are going to retrieve an index, and we are going to return the string with a path, but we would like to change the name for sure. So we are retrieving the image, get coffee selection button image, and I'm going to change the colors to actually paths to resources. First one is the cafe latte, then there is cappuccino.png, espresso ristretto, and the default one is a cafe latte. Okay, right, and right now we have to modify the button. So the item color is held in the color property, and I will create another property to hold an image. Let's call it item image, and exactly the same helper functions get coffee selection button image, and let's provide a coffee index to retrieve the image based on the index. Let's remove item color. We won't no longer use that, and let's replace the rectangle with actually an image. Size and the color is no longer needed. All right. And we will need source, which is then item image. So our property from the top, and opacity will be different for the pressed and for the normal state. So while user will be pressing the button, we will provide them feedback, the visual feedback that someone is pressing, and we'll manipulate the opacity. Opacity will be lower, 50% for the pressed case. And how to handle that? There is a mouse area. Let's give it some ID. Mouse, and depends on mouse pressed. This property is holding information if anyone is pressing the mouse area currently. So if it's pressed, I'm going to have a 50% opacity, and if not, it's full 100 opacity. And this is a binding that works normally exactly the same way as in a BigQt. And once the pressed will change, it will update the whole expression, and the result will be will be attached to the opacity property. So we do not have to care about updating it in the runtime. It's done automatically. And still we need some updates for coffee parameters screen. And there is still no logo. And let's copy that helper functions get coffee selection button image call. And let's go to coffee parameters. And there is an image which has an empty source. We have to just paste that line there. All right, to have exactly the same image on the, sorry, this target. Let's get back to desktop, release. And this parameter screen will right now will show this selected coffee next to the text that is indicating the type of it. Start, and brilliantly we have our icons on the coffee selection screen. Let's pick espresso, and as you can see, also there is a logo of selected coffee. All right, latte macchiato works as well, and still the back button has no asset attached. So let's fix that. Go to backbutton.qml, and well, we are once again replacing rectangle with an item with an image. We are removing the color and the size. We need a source, and again here depends on mouse pressed. We will pick different asset. So if it's pressed, it will be QRC button back down, and if it's not, it's normal, and we are no longer using a text element. So I'm just removing it. All right, so no change there as well. And we are picking Cafe Mocha. And right now our button has a nice back arrow, which changes the color. So in fact, the whole asset is changed. Depends on if we are pressing it or not. All right, let's verify that on the device. So I will just compile it and let it flash. And in the meantime, I will show you what are the intermediate artifacts that are produced for each asset during the compilation process. So once again, I'm inside our training directory, and I'm going to show you how our assets look like on the C++ side. So I'm going to build directory for the Renesas board, and let's pick one of the assets, which is, for example, tool resource button back. And this is an artifact file, automatically generated one. So you can see that our image is held as an array of bytes, and we can try to search for its type. It's an alpha 8, so it's an alpha map that holds our back button. And for example, Cafe Latte is a bigger array of our binary data that's in format ARGB32. And the same goes for all other artifacts and all other images that are attached to our application project. Okay, our app has flashed successfully, so I'm switching the view to secondary camera. And let's verify if that also works on a device. So perfectly, you can see that our assets are flashed to the board, and exactly in the same way they are drawn on the screen with a platform interface for our Renesas board. Let's get back to presentation. Well, so this is it for this live coding session. And that's it for today. So we covered all of the topics that were in the agenda. And well, right now I have a question to you. If you have any more questions, I can answer all of your well, maybe ideas, maybe something that was not clear enough. And there is still a time for asking those in the Q&A section, so I can take cover on those. I will still wait a bit to type those questions if there's anyone who is typing. You can also use my email address that you can see right now on the screen. You can write your questions there. I will try to answer those as soon as it's possible for me. All right. So I see that there are no questions at all. So thank you very much once more, and see you soon tomorrow on the second day of Qt4 MCUs training, the Getting Started one. And well, have a nice day. Thank you very much.